Our next topic is multithreading. All the code we've been writing so far is designed for sequential execution in a single thread. And what if we want two methods to be performed simultaneously? For example, we would be able to use our program, and at the same time, there would be a clock on top of it to check the time. Multi-threaded programming is designed just for that, and Java supports it. You encounter multi-threading every day. For example, in your web browser, you can turn on the music in one tab and read something, watch a video, or do anything else in another tab. In order to create a new thread, we need two classes which are written by other programmers. It's class thread and interface runnable. Let's code a sort of a timer. It will print out numbers 1, 2, 3, and so on every second, one after another. Let's create a new project for that. Call it multi-threading. Create a new class main and a program entry point. In order to launch the timer in a different thread, a thread must be created. This is accomplished by an object of the thread class. Write thread, call it timer, write an assign symbol and new thread. Our new thread has been created, but it's idle. For this thread to perform an operation, it must accept as a parameter an object of the class which implements the runnable interface. If we press Ctrl P, you will see different overloads. One of them does not accept any parameters. Next one accepts the runnable type. We have done something like this when we were studying interfaces. Do you remember the example of a director and a chef? Back then, we passed an object implementing an interface to a method. And here it must be passed to a parameter of a constructor. You might remember that we have two ways of adding a required parameter. The first one is creating a separate class which implements the interface runnable, and then creating an object of this class and passing it as a parameter. Let's go for it. And thus, we'll also review interfaces. It won't go amiss. Create a new class. Let it be called runnable timer. This class implements interface runnable. We have an error because we must implement all the required methods. Let's see what methods are here. Press Ctrl I, and here is one method run. Override it. You can see that this method does not return any values or accept parameters. Here we must specify the action which will be performed in another thread. Let this method print out number 1 1,000,000 times. Create a loop for int equals 0, I is less than 1,000,000, I++. We are printing out the number 1. Now in class main, create an object of the class runnable timer and pass it as a parameter to the constructor thread. So the thread has been created and we must start it. Write timer.start. Run the program. We can see that 1's being printed out. But how do we know this method is executed in a different thread? Let's go to class main and print out number 2 1,000,000 times. Normally, these loops would be in a queue, and first of all 1,000,000 ones would be displayed, and then 1,000,000 of 2's. But since the first loop has been started in a different thread, these two loops will be working simultaneously, and both 1's and 2's will be displayed. Run the program, and you can see 2, 1, 2, 1, and so on. Everything put out in the method main is called the main thread. Other threads are called background threads. In this case, we want to use this timer only once, So we could easily do with an anonymous class. Let's correct this. Delete the object of the runnable timer type and write as a parameter new runnable. Here we must override method run. Let it do what it's been doing. Copy this code and paste it here. Run the program. Everything works the same way as it worked. The code works, but this is not what we want. We wanted to print out one number, sleep for a second, and print out another number, then sleep for a second. Then we would have a timer. Let's print out not one, but next number every time. So we'll print out I. Let's delete this loop. If we run it now, we'll have different numbers printed out a million times. 1, 2, 3, 4, 5, 6, and so on, up to a million. But we want to make this thread sleep for a second after each number it prints out, and then to print out next number and sleep for a second again, and so on. To do so, we can call a static method sleep for the class thread. Write the following: thread.sleep. As a parameter, we must pass a number of milliseconds. A second has 1000 milliseconds, so let's pass 1000. We get an error warning here. Let's hover over the mouse over it and read what is written there. It says that an exception is unhandled, interrupted exception. It's just the case when we must use try-catch. Java has many situations when an operation can terminate unsuccessfully. Failure to read data from the internet, failure to convert a string to JSON, and these errors can provoke exceptions. All the operations must be wrapped in try-catch code. If we interrupt a thread while it's sleeping, it will provoke an exception called interrupted exception. Wrap this in the try-catch block. As you can see, we can do so with the method thread.sleep itself. Write try. Let's catch a general exception. We will not write interrupted exception, and it will not have an error. But imagine that an exception has arisen, and we have caught it. Our loop will not be terminated. It will continue executing. It will attempt to send the thread to sleep once again, and the error will occur again. And this will take place a million times. Therefore, if an action in a loop may provoke an exception, the whole loop must be wrapped in the try-catch block. Let's move our code there and delete this try-catch. We'll be trying to catch a general exception, exception E. Now the error is resolved. Let's run the project and take a look at what is going on. 1, 0, 2, and so on. Our timer works. To make sure that this timer is running not in the main thread, create the same timer. Here we'll abort the program. Let it be called timer 2. And let our first timer print out ones, and the second timer will print out twos. Run the project. We can see that every second, number 1 and 2 are printed out one by one. It means that both of these threads are working, not in the main thread. We can create as many threads as we like for them to perform different tasks. Now our timers will print out numbers a million times, but usually timers are not limited to a million. We want a timer to work infinitely until it's stopped manually, so that a condition always applies. We can use a while loop instead of the for loop. Let's delete the second timer. We have already made sure that they work in different threads. Create a while loop. Create a variable which will store the current seconds. We'll print out I, then increment the value of I by 1 and send the thread to sleep. Delete the for loop. So the timer is ready. But what must be set as the condition of while? the loop must be executed infinitely. So we can write something like, while 1 is less than 5. This condition will always apply and the loop will be executed infinitely. But we can specify the Boolean type so as to write simply while true. Thus our timer will be working infinitely. Run the project. 0, 1, 2, 3, and so on. Our timer works. Well done! It may happen so that we have to work with one variable in two different threads. Let's, for example, create another timer. Call it timer2 again. We want this timer to work until the first timer counts 5. How can this be done? For that, the condition of the while loop must be not true, but while the number is not equal 5. It would be a good idea to create a Boolean variable. Let's do it. Boolean, call it is5, and assign it false. And in the loop, we must write while it's not is5, that is, while it's not 5. Check the condition in the first loop. If I equals 5, then variable is5 is assigned true. But here is an error. We are trying to assign a value to a variable which was declared not within this thread, but outside of it. It's required to declare the variable outside this method too as an instance variable. Let's create a variable. Boolean is 5, assign symbol false, and let's delete this declaration. In this case, we're having an error because our method main is static. And you should remember that we cannot address instance variables from a static method. In this case, the variable must be also declared as static. And so this problem is solved. Let's run the project. We can see that the numbers are displayed in a sequence. Once we have reached 5, one of the timers stopped working. So our lesson is over. Now it's the time for homework. Within the main thread, create an int variable, which is assigned random values from 0 to 1 million. Then create two threads. One of them will be a timer. Every second, it will print out numbers in numerical order. The second thread will try to guess the random number by generating random numbers too. When this thread makes a right guess, it must stop, and this number must be displayed on the screen. To solve this problem, use a Boolean variable. Do not forget to be able to use the same variable in both threads. You must declare this variable static and not in method main. Pause the playback of this video and try to find the solution on your own, and then resume the playback to watch me solve this problem. Good luck! So I hope you have completed the task. Let's delete all this code from here. First of all, create an int variable. Let's call it random. Assign it the following value, cast to the int type. Math.random times 1 million. Now create two threads. The first one will be a timer, so we'll call it timer and pass it an anonymous class newRunnable as a parameter. This timer will print out numbers until the player makes a right guess. Let's create a Boolean variable. It must be static. Call it win and assign it false as an initial value. We'll print out the timer until the player wins. Right, while not win, we are printing out variable I. We have not created it yet. Let's create this. Increment its value by 1 and send the thread to sleep for a second. Here we must wrap all our loop in try-catch block. IntelliJ IDEA allows doing it very fast. Select the whole loop, press Ctrl-Alt-T, and select what it must be wrapped into. We want to wrap it in try-catch. Select menu item 6. Our loop has been wrapped in try-catch, and an interrupted exception will be caught. In the catch block, print stack trace method is called for our exception. It's not clear, but don't worry. It simply prints out information about an error on the console. You can even delete it or leave it empty. This will not cause any trouble. It's used for program debugging purposes. Thus, we can get information about what exactly happened to our program, why an exception arose, and so on. Create another thread, which will be trying to guess the number. It will be our player, so call it player. Use the same anonymous class. We'll try to guess the number in method main. Save it into an int variable, guess number, a guess number. Assign symbol. It will be a random number too. Math.random times 1,000,000 semicolon. So in case we guessed, write if guess number is equal to random, the random number. Assign true as a value to a variable when, and our timer will stop printing out. And we'll also print out the guess number on the screen. Shout guess number. To check that the player did actually guess the number, let's print out the initial value of variable random. So the number to guess, which is below 1,000,000, will be printed out on the screen, and then the timer will be set, and it will print out the number of seconds until the player guesses the number. All we still have to do is to start the threads by calling method start. Write timer.start, player.start. And this must be done in an infinite loop which is broken when we win, while not win. Run the code. It took too little time. Let's make it 10,000,000. It was guessed in 0 seconds again. Let's make it 100,000,000. 0 seconds again. The CPU is very fast. Let's make it 1,000,000,000 values. The number is 791,000,000. Let's see how fast it will guess. So it only took 17 seconds. My congratulations, the program works great. We will meet in our next video.